Doing another virtual star party tonight, the night of August 19th, 2012. And so tonight, we've got, it's just the core group of astronomers tonight, but we've got some beautiful views. So we've got Chris Ridgway, who's in Indiana, and he's showing us this beautiful view of the Swan Nebula. Hey, Chris.
Hello.
And we got Gary Gonella, who is giving us M31 Andromeda, and people have been asking us for Andromeda for months now, and Andromeda is now back. It's an object in the early evening, and we'll be able to show it, although not as nice as it will get sort of further on in the year. Right now, it's still quite low and fairly disturbed atmospherically. So this is what Gary is showing us. Hey, Gary.
Hey, how are you? I'm looking
and then we got Stuart Forman, who is in San Francisco area, and he's just in the process of calibrating his telescope. We thought we'd just go live and
do you see my M13 right there? Or is...
I do. Yeah.
Okay,
yeah, it
good.
looks great. Well, it looks very blue.
Well, that's because it's still light out.
Yeah, I know. So just to keep in mind that Chris is about 2 time zones ahead of Gary and Stuart. So this is where we are. So why don't we start moving around? So first, let's go with Chris, because this is beautiful, Chris. So this is the Swan Nebula.
Right.
And what's your method for capturing this one?
Well, using my Meade 8-inch LX90, it's a Schmidt scope, and I've got my Canon T3 on the back of it, and I'm taking a 60-second sub. So this is a 60-second image here.
And it's also known as M17, right?
M17, yes.
Yeah. Let me see if I can show this for people here. Unfortunately, Scott's feeling a little under the weather. He's got a bad back. It's kind of hurting him tonight, and I'm not sure where Pamela and Phil are. So it's I'm going to be the all of the color commentary tonight. But
It will help.
Yeah, well, exactly. I mean, normally you guys are so busy working the telescopes. We got so many interesting things to say. So, yeah. So let me just show the location here. This is going to work, man. Google Plus doesn't work so well on Linux. There we go. So this is this is Sagittarius. You can see the constellation, and then let's zoom in. Whoop. You get it here? So it's also known as the All right, so that's sort of what I guess we see as a simulation of it. And then back out here. And so you can see it's just in the constellation of just above Sagittarius, which is great. Sagittarius is one of these constellations that doesn't look anything like what they say it's supposed to look like, but it really looks like a teapot. So you can see it down sort of on the horizon in most, like right now as one of the summer constellations.
And the Milky Way is the steam coming out of the teapot.
Yeah, the first time I had that pointed out to me under dark skies, I was amazed.
Yeah, I guess from Los Angeles, you don't really see the dark skies that well, eh?
No, I can't tell it's there.
Yeah, I get it pretty good where I live. We got one street light, which my wife and I really plan to vandalize. Because if we could get rid of that one streetlight, then we would have a really nice dark sort of front yard, backyard, get a really nice view to go out and look at meteors. But right now what we have is this horrible streetlight that's like right over our house, right over our front yard. So we sit out on the front yard trying to look at meteors. We're just getting pelted by this by the photons from this awful streetlight. So that's great. So and then we'll move on. But Chris, what else have you got in your sky there? What are you going to go for next?
Oh, well, I'll probably
as well?
Yeah, I can try M31.
Okay, that'd be great. And then we'll move over to Gary. So Gary, this is like an old friend of ours, isn't it? M31.
Yes, it is. Yes, it is. And it's 2 companions, what is it, 32 and 110?
So M31, also known as Andromeda, this is the I guess the largest, most distant object that you can see with the unaided eye. It's a big galaxy, bigger than the Milky Way, and it's actually on a collision course with us, and we'll collide and sort of gobble us up in the next 7.5 billion years or so.
Yeah, it's our closest neighbor. And you mentioned that we're just getting it. I'll put my scope here real quick. You can see how low I am to the horizon.
Yeah.
I'm just barely shooting over the edge of the observatory. So as the weeks come through here, it's going to come in better and better.
Yeah. So I'll show people where to find it. Now, if you want to see it, so the easiest way to do it is you look for the Big Dipper, right? So there's Ursa Major, and so I hope everyone can find the Big Dipper now. And then, as always, you follow the two end of the stars to Ursa Minor, and that's the North Star, and then you can see the Little Dipper there. And then if you move over, you can see another really familiar constellation is Cassiopeia, and it's that W that you see in the sky. And then just below Cassiopeia, there's kind of two constellations that are really important. One, although it hasn't really come up yet right now, is Perseus. And this is where the Perseid meteor shower come, and there's the double cluster in there, which we might take a look at if we get a chance. But then to the sort of right and below Cassiopeia is this constellation of Andromeda. And you can see here that Andromeda, you can sort of really recognize it's got these 3 stars, and then the middle star has got these 2 stars above it. And Andromeda is just above this smaller star. So I always walk up Andromeda. I start at this sort of middle star, I go up to the one above it, then to the one above that, and then a little to the right and above, and that's where you can see Andromeda. And if you have really nice dark skies, you can actually see it with the unaided eye. You don't need to have even telescopes, binoculars, anything. You can see this smudgy patch in the sky, and that's Andromeda. So, and it's great. I mean, we were seeing M31 all through the fall and into the winter, and then we lose it. And so now we get it back, but it's very low on the horizon. And so this is one of these problems that what we really want to look at when we're doing observing is you want to look at the stuff when it's directly overhead, when it's, what is it, the zenith? Is that right? Did I get that right?
Right.
Correct.
Yeah, you want to see the stuff when it's directly overhead because that's when you got the least amount of atmospheric distortion. You've got, but when you're sort of down looking at stuff on the horizon, you're looking through more atmosphere, and so anything you're seeing is just getting worse and worse, polluted by the atmosphere. So, and unfortunately, right now, this is how good it can look for Gary. But give us another couple of months, and when this gets a lot higher up in the sky, it really clears up and gets quite beautiful. Chris, you're going to do M31 as well?
Yeah, I'm taking one right now.
Okay, all right. And I think we've got some questions here.
I got the Ring Nebula here.
Oh, great. Can you embiggen that? Because it's pretty wee.
Yeah, I can in a different program. It'll take me a minute.
Sure. Why don't you do that? Because it's so tiny, right? So John Native asked, how can we be expanding when we are colliding? So I guess the question is, like, how can we be colliding with Andromeda when at the same time the whole universe is expanding? And so the universe is expanding at sort of large scale structures, and so if you look at in any direction, you look at these galaxy clusters, we're roughly expanding away from these galaxy clusters, or these galaxy clusters are expanding away from us in all different directions at roughly the same speeds anywhere that we look, and that's one of these clues that tells us that the whole universe is expanding. And this is what led to this idea of the Big Bang. But in a local level, you can have gravitational interactions that are sort of above or more strong than this expansion of the universe. And so you get these situations where, at a local level, these galaxies are gravitationally interacting with each other, colliding, tearing each other apart, and just generally, creating these larger, more complicated, or different kinds of galaxies. And so you can have this expansion at a large scale, but you can have collisions and interactions at a local scale when the gravity overpowers the expansion. Cool. So yeah. So by the way, you can ask any questions you want. We're happy to answer them. Not me. We've got amateur astronomers here who know their stuff. So we're happy to answer any questions you've got. So feel free to ask your questions. You can ask your questions in, if you're watching this on YouTube, you can ask it there. If you're watching this on Google Plus, you can ask it there. If you're watching this embedded somewhere, you can post it into Twitter using the hashtag StarParty. And then the last thing is if you're actually like watching the event where we were planning this event, you can post your questions there. The only problem is the tool that I'm using to bring in those questions doesn't work very well with events, so I'm not sure I'll catch them all. So I highly recommend that instead you actually go to Google+, or if you're watching this on YouTube, click to go to the actual YouTube site, and then we'll answer the questions there. So if I'm not answering those questions really quickly, that's what's going on. So. Okay. Well, Gary's moved on, so why don't we move on to what Gary's got, and then we'll come back.
Okay. This is NGC 281, called the Pac-Man Nebula,
That's awesome.
and you can see all the nice. Yeah, there we go. It's got dark lanes, but you can see the Pac-Man. If you look real careful, it's kind of turned sideways.
Yep, I totally see it.
So that's always a fun one. And I don't know.
What did they call it before Pac-Man was invented?
NGC 281.
281.
I still don't see Pac-Man myself.
You don't see it?
No.
Well, it's kind of like
Here's the mouth.
yeah.
This is the Pac-Man, and here's the mouth, and it's going chomp, 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 chomp.
It's eating stars.
Yes.
So the Pac-Man Nebula is right. So here's Cassiopeia. You can see, and then it's right underneath Cassiopeia, and so we'll zoom right in and see if they've even got that. No, they don't. They don't show it. So, but there it is, right there. That's great.
Okay. And I've got.
Can you grab the double cluster? Do you think, Chris? After this,
I can try.
it's in the sort of same region as well, right?
Depending on where it's at. What am I looking for here?
It's right in between Cassiopeia and Perseus, so it should be pretty easy to grab.
Okay, am I embiggened?
Yeah, you are. So oh, I love that picture. Look at that. That is fantastic.
This is a 60-second shot.
Yep.
And this is I had to take it again because I had to do it in JPEG so I can get this program working.
That's fine.
But
Yep.
yeah.
Yeah. So this is the Ring Nebula, aka M57.
57.
Yeah.
Yes, 57.
And it's a planetary nebula. So it's kind of an idea of what our sun is going to look like about 5 billion years from now, when the sun has exhausted all of its fuel, burnt up all of the hydrogen in its core, turned that into helium, puffed out its outer layers, and then collapsed into a white dwarf. And so these are these outer layers that are still expanding outward and illuminated by the dying star. And so this is the kind of thing that our sun is going to go through. And I love M57. I mean, we try to... I mean, again, this is one of those times, here we are in the summer. This is when M57 is really easy to see, and it's sort of right next to one of the brightest stars. So again, I will show you, if you've got a small telescope, a 4-inch telescope, or even like a nice pair of binoculars, you can make out the Ring Nebula. You won't get much more than a ring. You're probably not going to get that beautiful color in the middle, though. That takes a little bit of a higher, better telescope. But let me show you here what we're looking at. So, I should, if I can find it. There we go. Hey, okay. So it's in the constellation of Lyra, and this is and so one of the ways to really find Lyra is the bright star Vega, and Vega is like right overhead right now.
On the Pacific, yeah.
On the Pacific, yeah, it's moving down right now. But the other important thing is that it's part of the summer triangle. So there's 3 really bright stars that you can always see all summer long, right? You get Vega, you get Deneb, and you get Altair. And so this is the summer triangle. And seriously, I mean, if you don't know the summer triangle, then this is your first constellation to learn. And the great thing about Vega is then it's got these. It's a small constellation. It's got 5 bright stars in it that sort of follow the shape, and you can see in between these last 2 stars as we zoom in. Right there is the Ring Nebula, and so it's really easy to find because it's just in between Chiliac and Sulafat, but it's right in between them, and so it's really easy to find your way to one of the bright stars and then just move yourself in between those 2 stars and you can find it.
Yeah, it's right smack dab in the middle. It's one of the easiest objects to find with a beginning scope.
Yeah, again, it's sort of one of those great objects, and hopefully we can look at M17 as well. It's another one of those. Hey, it's moving. Look at that. I forgot to connect it to the. Oh, well, that didn't work. All right, I'll stop that. Yeah. So that's beautiful. Oh, you've already moved on. Everyone's moving on. Okay. All right. Well, let's hurry up then. Okay, I got to catch up then. Let's talk more. C. So Chris has gone back to M31. So this is Chris's version of Andromeda, and it's beautiful. I mean, it's a really great view, Chris.
Yeah, that's it. And that's a 70-second image. I don't get as good a detail as Gary might get. My setup's not quite the same, so but you can still see the dust lanes.
Yeah,
Right there.
yeah, absolutely. Yeah, there's the dust lanes, and you can see
Central
that satellite galaxy. And of course, in your case,
Right
it's rotated around. So in Gary's, that was in the upper left, and now it's
Right.
now it's down below.
Right.
Yeah. So BTL 743 wanted to know if this was live. Yeah, right now everything we're viewing is live. In that, this picture was the last picture that they took with their telescope and camera 30 seconds ago. So, you know, we don't actually do video for the deep sky stuff. We actually have to take longer exposures to do some of the deep sky stuff. But it's all done live. So we're, you know, whatever is up and whatever we're getting in currently, that's what we're seeing. So John Ducrest asks, and this is great for the astronomers, he's got a Orion 8-inch go-to, and he's been told that he cannot do AP, I guess astrophotography with a Dobsonian. How true is that? If it tracks, I could at least get 1 minute. So should I focus on that or Schmidt-Cassegrain? What do you think? Did that question make sense?
It made perfect sense. And he could do photography as long as it's short enough. I have a friend who has a much larger Dobsonian who's able to get like 15-second shots, and they're beautiful shots.
Yeah.
And so, yeah, there's nothing to prevent him from sticking a camera on his thing and trying. It just needs to be balanced correctly so the scope doesn't flop around all over the place.
Yeah, one of our more heroic members of the Star Party team is Corey Schmitz, and he's got a beautiful, gigantic, like a 10-inch Dobsonian, but he has to hand guide it, and so it's really good on the moon and the planets and things like that. Although you can see him constantly making adjustments. So if you want to go the astrophotography route, I think you're going to want to save yourself the pain and go straight to a Schmidt-Cassegrain, or
Actually,
just something with a guided mount that lets you take longer photographs, right?
let me add to that, Fraser. Corey just posted some new photographs with his Zoomel Z10, and he built an equatorial platform that is motor-driven. And he said he was able to track the sun for 5 minutes. So a Dobsonian with a home-built platform, you could do AP just like we're doing right now. So yes, you can really.
Yeah, and so again, this is sort of, you got to see this machine that Corey has built, right? He's home-built a platform, like a wedge, that puts his Dobsonian at an equatorial angle so that we can see, so that it can then be at the same angle as the Earth's tilt. And so at that point, he's able to then follow objects along the, I guess as the Earth is rotating and the objects are moving in the night sky, he's able to follow them, and then he's able to collect more light from a single object. And then he's motor driven. I thought he was hand driving it. He's got it motor driven.
No, he put a aftermarket Celestron motor on the bottom of the platform. And runs it with a motor drive. He's still not, go-to like we are.
Yeah.
But he's still able to run that motor and follow or track an object a little bit, not with quite the precision that Gary can or that Stuart or myself can, but 5 minutes of holding the sun in the center of his eyepiece is pretty good, I think.
Yeah, totally. But I think for these longer exposures, I think you really will want to go to. I mean, Gary's, for example, with a separate tracking scope, he can resolve the same object for hours if need be, right?
Yeah, I can track 2 to 3 hours and keep it lined.
Yeah, so that's all. I mean, just at a certain point, it's really about how well, it's all about the mount, right? How well can you keep an object aligned in your telescope for a long enough time that you can get the kind of exposure that you really want. So,
well, and the advice that I give people, and I've talked to several people at the club, is start simple and only try to solve one problem at a time. See what you're getting, say, okay, now I want to play with tracking. Well, if you're playing with tracking, don't be too concerned about exposure. I've seen too many people try to do it all, and I try to do it all at the same time, and you just confuse yourself. So pick one thing.
Fraser?
Yep.
I gotta sign off. I'm gonna keep my image up. This is Epsilon Lyra. You can talk about this, but I'm gonna be off for about 15 minutes. I got something at work I got to deal with.
Okay, sure. For anyone who doesn't know, Stuart is a doctor, like a surgeon, so he sometimes has to take off. So Gary, what have you got here?
Okay, this is IC 1396. It's called the Elephant Trunk. This is an area where there's a lot of nebulosity going on, a lot of glowing hydrogen, and there's dark. I have to look over here. There's dark clouds in front of it. So what you're seeing here is the dark cloud. You're seeing the dark lanes here. I think this is the one they call the Elephant Trunk, but I won't swear to that because I haven't been able to look it up. But you got the nice dark over here and some bright stars in between. So this is an area that's got a lot of little fiddly bits.
That looks beautiful. It looks like a pretty big region.
Yeah, it's huge.
Yeah,
Very
and it's
big.
a lot of really faint structures and features. That's really nice.
And you're running a really wide field of view, and you still can't get it all in. That's
yeah, and I don't think we've ever seen this before.
I think I tried once and couldn't get it. But you can see the more detail in here when I zoom in. Now this is a 60-second, and I binned it 4x4, which is what works out best for the star parties. And for those who don't know, what I'm taking is 4 pixels across and 4 pixels down, so 16 pixels, and I'm using the light from those for 1 pixel. So I'm basically multiplying the light I get 16 times.
So we've got a new person joining us, Thad. Am I getting this right? Thad Szabo? Szabo? Szabo, yeah. Szabo?
Good evening, Thad.
Long A. Szabo.
Szabo. Thad Szabo. All right, cool.
It's
awesome.
Okay.
So Thad has actually participated in a couple of sort of ad hoc star parties that we've done. I guess last week there was an occultation of Venus by the moon. It was only happening in the daytime, and so we had these grandiose plans to try and capture that, but weather was conspiring against us. But yeah, so Thad and Scott were attempting to image that. So, and you're down in the LA area as well, right?
Yeah, I'm in Los Angeles and deep in all of the light pollution. So tonight, with no visible moon, no really visible planets, not too much point in setting up where I am. So,
but you've actually got some serious astronomy experience and cred, right? You're doing some astronomy work, right?
Yeah, I finished my PhD at USC 2 years ago, and I teach at Cerritos College. And tomorrow's the first day of the semester, so I'm looking forward to getting a whole bunch of new, fresh minds in there.
So I will be able to rely on you for a little bit of the color commentary tonight.
Absolutely.
Awesome.
Yeah, you teach out kind of my way.
Yeah. Yep. Okay.
Okay, well then I'm going to throw a question at you then. So we got a question from John. How can gravitational forces have accumulated in an expanding universe?
So this is a great cosmology question, and something that's always kind of fun to try to get across to my students when we get to this part of the courses. The thing is, yes, the universe was expanding from the time of the Big Bang, but with all of the matter in the universe, it was slowing the expansion for quite a while. I mean, if you think of it as, you take an object and you throw it away from the Earth, gravity will work on it to slow it down. Even if you were to throw something at faster than the escape velocity, gravity would still be working on it to slow it down. And so this does describe what was going on in the universe up until probably about 5 billion years ago or so. At that point, dark energy would have kicked in and would have started to increase the rate of the expansion again. So the other thing is, with the accumulation of forces, anywhere you have enough mass so that the local density of the universe in that region is higher than the density needed to close the universe, that region of the universe will stay closed. So, for example, you're not getting any bigger because of the expansion of the universe. The Earth isn't getting any bigger. The distance from the Earth to the Sun isn't getting any bigger. This is all bound by gravity. Gravity is strong enough in that local region to prevent expansion from happening. The Milky Way galaxy isn't getting bigger, and any clusters of galaxies are held together by enough mass, there's enough gravity there to prevent expansion from dragging them apart from one another. It's only places where the density of matter drops off to so low that expansion starts to be the predominant effect. So anywhere where there's enough matter around, you don't see local expansion of the universe. It's only on much, much bigger scales.
There we go, John. Thad just answered your question like crazy, so that's awesome. Okay, so I've actually asked Chris to move to the double cluster, and can you grab another one, Chris, to actually get both parts of the cluster in view? Because you've only got, I think, one part of it.
I'm back.
Okay, great. We barely even moved. So the double cluster. Let me sort of give people a little perspective, because this is another one of these really beautiful images, and I really like this one for binoculars. So if you've got like a regular set of binoculars, you can see the double cluster. So again, here's Cassiopeia, right? And then just below Cassiopeia is Perseus, which looks like this big upside down V. I don't know sure why the lines aren't showing, but and so halfway in between them is the double cluster. And again, it's one of these objects that you can see with the unaided eye, but when you see it in a telescope, then you get this really cool double star cluster. And so you can see here, and we've lost it from Chris, but you can see these two clusters of stars here, and it's a great object to look for with binoculars and a small telescope.
It's my favorite.
Is that one of your favorites?
It's my favorite. It's my absolute favorite.
Yeah. I mean, it's one of those things that if it's up and I've got binoculars, I'll go, oh, check this out, and then I'll point it out, and that's a good way to get started.
I'm working on a new picture, Fraser.
Okay. Have you shown mine yet? Because I'm going to move on.
No. Let's see what we're looking at here.
So this is the double, also in Lyra. It's right next to the Ring Nebula. It's really near it, and what we're looking at is here and here. If you just look at it with binoculars, it looks like a regular double star, but with a telescope, you'll see that each of these stars resolves into two separate stars, there and there, and there and there.
But this isn't one of those situations where you can resolve it like one with your eyes and then one better with binoculars or telescopes. Like
well, if you look with your eye, it looks like one star. With binoculars, it looks like two stars, and with a telescope, it's four.
Okay, well there you go. That's really cool.
If I remember correctly, both binary pairs are actually in orbit around each other, if I recall correctly. So each binary pair, you have the two within the pair in orbit, and the two pairs, if I'm remembering correctly, also orbit each other. So it's a pretty complex system. Am I recalling? I
think you're correct. I don't have access to the databases right now, but somebody who could look it up. But I think you're right.
There we go. Although it's a little blurry, Chris.
Yeah, I just moved the scope. It's going to be more blurry, I think, here because I just kind of bumped it.
Yeah. Okay.
But I was able to get both the clusters in the view here.
So again, we're glad to take requests if anybody wants to see anything specific. Otherwise, we'll just follow our own dread plan. Gary, what have you got here?
The Lagoon Nebula.
Oh, nice.
I was actually trying to get one that I just found today that's called Gomez's Hamburger. Gomez's Hamburger, yes. And it's behind a tree for me right now. I have no idea what it is. I just found it on the star chart today and said, I've got to look at Gomez's Hamburger, but I couldn't get it. It's sitting behind a tree for me right now. But this is a lagoon, basically a glowing patch of hydrogen. Just so any newcomers that haven't been to it before, I'm taking images through what's called a hydrogen alpha filter. So I am looking at a very narrow band of light that is given off by excited hydrogen. and it's in the red range. So when you see a true color image, you'll see this show up as a red. And being in the Los Angeles basin, I'm very light polluted, so I have to pretty much take with narrowband filters to get this kind of detail.
And we're actually in a really wonderful time of the summer when we can see the center of the Milky Way. So remember I mentioned that Sagittarius was this teapot constellation. Well, the very center of the Milky Way is in this region. And so you're going to see a lot of really nice star clusters and a lot of nebulosity and all kinds of great stuff in that region. And so here is the Lagoon Nebula. Let's see if that's going to take us. Oh, yeah. So it's right there. So it's just above Sagittarius.
So actually, Fraser, could you go back out to the large-scale view of Sagittarius there? Just something I want to point out for people who are concerned about 2012. So, I mean, this is the whole idea behind this is the prediction of some alignment between the sun on winter solstice and the center of the Milky Way galaxy. So if we go back to the view with Stellarium there, let's see.
What do you want to see?
Right, yeah, right. If you can go back to Stellarium, just because right now I'm getting the dumbbell as the main view.
No, that's okay. I'm on Stellarium. You just have to click.
Okay.
The viewers are seeing
okay,
Stellarium.
sorry. Yeah, still adjusting to this.
Yeah.
All right, so if you look at this,
I have the dumbbell. Sorry.
Okay.
Yeah.
So if you look at the spout of the teapot, right? So there's the two stars that mark the top of the spout, and you come forward toward the direction of Scorpius just a little bit. It's in the direction of the butterfly and Ptolemy's, or of the butterfly cluster. That's where the center of the galaxy is, just a little bit below, I guess, where NGC 6451 is on that view.
Yeah.
So that's where you're looking at for the center of the galaxy. If you scroll back up to where the Lagoon Nebula is, that's about where the sun will be on the winter solstice. That's not an alignment. if you call that an alignment, I don't want to play pool with you as my partner. I don't want to play horseshoes with you as my partner because you're going to miss just all the time. And so this whole idea of, oh, there's an alignment, no. You can actually fit 14 full moons in the sky between where the center of the galaxy is and where the sun will be on winter solstice.
Yeah, I mean, hasn't this alignment happened like in 1980 or so? We're getting less aligned every year.
I'm not sure what precession is doing as far as the closeness goes, but again, it's still no closer than 14 full moons apart.
Yeah.
So, yeah, and every year, I mean, the sun, it's near the ecliptic. The sun gets near that part of the sky every year. Again, it's just people really just trying to make a buck off of you buying their book or watching their movie. Yeah.
So. Yeah, exactly. What have you got there, Stuart?
This is
a coat hanger?
No, this is NGC 6910. It's an open cluster in Cygnus that I always thought it was pretty because you can kind of see just wisps of stars coming up. It sort of looks like a little starfish to me.
Oh, yeah. Yeah.
That's cool. Can you get the coat hanger?
I can try. Gary would probably be better at it because his field of view is much bigger than mine.
Okay, yeah, it's a pretty big object. Again, this is one of those great ones that you look at with a small telescope or binoculars because it's just this. It is absolutely a coat hanger in the sky. But let's find out what Gary's got first. And I've got a request here for the Eagle Nebula, which would actually be great if it's still up.
I can try.
I can do the Eagle here too. This is one that I haven't imaged before. It's NGC 6589 and 6590. It again is in the Sagittarius area, so it's near the center. There's just a whole lot of activity going on there, and this is a very big. Here's one nebula here, but I think they're probably referring to this. I don't know which ones they're referring to as which number, but that's some nice nebulosity in there. Bring it up a little bit. There we go.
The one thing that shows up really terrifically when you're imaging in the thick of the Milky Way like this are dark nebulae. So if you have a really massive, really hot star in the region, it can get that hydrogen glowing. However, if you just have darker material that doesn't have something to light it up, so this kind of dark, cold material, you see a large region in this picture where there's just very few stars coming through. Well, it's not that there's an absence of stars, it's just there's material intervening between where we are in the galaxy and where the bulk of the stars would be. So what you're seeing, it's not an absence of stars, it's material that's blocking the view. And the one thing about this kind of cold, dark material, this is what can collapse to form new stars. I mean, yeah, nebulae look great, you get the emission nebulae, they're very pretty, but the things that are going to collapse to form new stars are going to be your dark molecular clouds. So anytime you see one of those, hey, could be stars a couple tens of thousands, millions of years from now. So
we've just been joined by John Kramer. John, are you clouded out tonight?
No, I've got some clear skies here. Just trying to share out what I can.
So Brad Clark wanted to know if we've got any planets tonight. We don't. Unfortunately, well, there are planets. They're just only visible to people in, like, Asia right now. So right now, Jupiter and Venus are morning objects right now, and Saturn and Mars are going down like right after sunset, so they're just not visible right now. So we're gonna have to wait until probably October, November for Jupiter and Venus to come back out to be evening objects, and they should be really nice. But we're still gonna wait another couple of months before we'll get some really good views of them. So
Eagle's behind a tree for me, but I've got the wild duck right now.
Oh, great.
So the wild duck, this is one of those clusters that, there are basically two types of star clusters that we know about, one being open star clusters, which is theorized to be the kind of region that our sun would have formed in with a loose grouping of other stars. The other type of star cluster is a globular cluster, and those seem to be left over possibly from the collisions between galaxies, and if you maybe have the Milky Way eat another galaxy, what could be left over is a globular cluster, which tend to have couple tens of thousands to up to more than 1 million stars. So the thing is, the wild duck, which is visible kind of off the head of Aquila the Eagle, it's actually in Scutum the Shield, but it's in along the thick of the Milky Way in the summertime in the northern hemisphere. It has so many stars that, well, they think it's an open cluster, but it kind of borders on the number of stars that you'd get with a globular cluster as well. So there's a little bit of an unresolved issue there with exactly how many stars there are available or visible, and exactly which type of cluster it is. Either way,
there we go. So now we've got a request for the Eagle Nebula, and so Gary has moved to the Eagle Nebula. And specifically, Gary, can you highlight the crowd-pleasing Pillars of Creation?
This is a 10-second. There's my 1-minute exposure. So we'll get a lot more detail here. So this is the whole area of the nebula. You can see the glowing gas way out here when you go into the faint areas. Now if we zoom in, I want to do that, and reduce the brightness a little bit. Darkness, and here is the famous Pillars of Creation.
Fantastic.
This one's a lot of fun. And if you go back a little bit, you can kind of see how they came up with the name Eagle with the wings coming off to both sides. At least that's how I see it. So, for whatever that's worth. But there's.
I think I have to turn my head right now, but yeah, I see it.
It's diving. It's going after a fish or something.
Yes,
yeah,
exactly.
Actually, you know what it looks like to me? It looks like a griffin, but I'm seeing like wings above a kind of. But I guess it all depends on the rotation. What you think you see. A butterfly.
Yeah.
Now what is this nebula specifically, Thad?
So this is another emission nebula. This is hydrogen gas, just as we discussed with the lagoon, that there's got to be an O-class star. So under the classification of stars, there's the whole O be a fine girl, kiss me, or O be a fine guy, or giraffe, or gorilla, whichever you want here, kiss me. O's are the hottest, then B's, then A's, then F. G is like our sun, and then K's, M's are the coolest stars that are actually producing energy. Some people will tack an L or a T on the end for brown dwarfs, but as far as I'm concerned, it's not quite a star. So an O-class star puts out so much ultraviolet radiation that it gets the electrons in hydrogen jumping up to higher energy levels. As the electrons fall back down, they emit light, and so that characteristic red light is what we're seeing from this excitation of the electrons in hydrogen. As the electrons fall back down, they emit this red light. So somewhere inside there has to be an O-class star to get it to glow like this. O-class stars don't live very long, but they're extremely massive, and when they die as supernovae. They will go to become 1 billion times more luminous. Basically something that if it was a star that could just be seen as a regular star in the nighttime sky, it would become as bright as, say, the planet Venus, or brighter if it goes supernova. So you're looking at very massive, short-lived stars, but really this is how material in the universe gets recycled. So you build an O-class star. It will light up the hydrogen very nicely for us to see as a nebula like this, but any elements heavier than carbon throughout the universe will be produced and distributed throughout the universe by the supernova explosion that occurs from one of these stars at the end of its life. So anytime you're looking at this, the Lagoon Nebula, the Eagle Nebula, the Swan, the Orion Nebula, any of these regions that glow with this characteristic red color, somewhere in there is an extremely massive star that's going to have a very short, violent life. But, like I said, it recycles the stuff of the universe and puts heavier elements out there that you can make planets and potentially life with.
Cool.
That's really cool. And so, and of course, because from what I understand, one of those O stars has actually probably gone supernova, detonated, and probably destroyed the pillars of creation. And so astronomers actually think that those pillars are gone now. And so we're seeing, we have to wait for the time that's going to take light to get here for us to be able to see those pillars actually crumbling from the...
So it's really the pillars of destruction?
Pillars of destruction, exactly, yeah. So we've got 2 more people joining us, which is fantastic. Look at this. We've got Corey. We were just saying nice things about you, Corey.
You were?
Yeah, we were talking about your cool, fancy new Dobsonian mount that you've built.
Well, that's if I'm trying to get the image that I took of M13 to show up for my first time ever using it.
I can see. Yeah, you need to go into the presentation mode of Backyardios.
That's what I did.
Yeah, and that'll do it.
Is it showing it right now?
Well, we're seeing it, but inside all of your histogram stuff.
Oh,
so
okay.
We're losing
to the right of the
resolution.
image, Corey, click to the second button directly to the right of the image.
Click the
There's
button.
second
Yes. Okay.
That one.
Right there. There you go.
Is it full screen now?
No.
Ah. It's full screen for me, but not for you.
We'll give it a
May
second.
take it a
Maybe it
second.
will.
Yeah.
Yeah.
It was
We'll
moving
get
kind of
something else
slow
here.
when he moved.
And then
I
we
got
got
something here.
and we've got Tom. Tom Nath has joined us too. Hey, Tom. Oh, you're muted. And I've got people playing basketball above me. I'm gonna go. Remind people that I'm recording here. I'll be back in 1 second. Feel free to talk amongst yourselves. I'm going to point this on Corey's view here while he gets this going.
No pressure, Corey.
No pressure.
Well, yeah, it's weird. Like, it's showing it full screen for me. Oh, it was? Okay. No, whose is that? That's not me.
I have the Eastern Veil, which you can kind of see in here.
I've got up
Alright,
a globular cluster as well.
Right. So which globular is this? Is this Chris?
Yeah,
got the
the
globular?
full screen view
Yeah.
is the M2.
M2. Okay, so this is an Aquarius. So Aquarius it rises right around sunset now. So this is a globular that would be up all night long for, just about everybody on the planet.
Yeah.
So tight little grouping of stars in the middle. But we can kind of contrast this with what we were looking at before with the wild duck cluster. So you can see, I mean, this looks like a ball, as opposed to the wild duck, which, okay, it was dense, but it looked more like kind of just a smear of stars over the sky. This definitely has like a ball-like structure. So this is kind of the contrast between a globular cluster, again, tens of thousands, up to possibly as many as 1 million stars for your biggest globulars, versus an open cluster, which could be a few hundred to a few thousand.
This is
nice
great.
shot.
Someone commenting on YouTube, "Stop playing around, Daddy's recording." That is exactly what I did. I'm upstairs and they are watching TV, bumping, playing with swords upstairs. So yeah, pretty funny. But I mean, we record so much around this house that I can't fault them. So this is good. So you've got M17 as well, right, Chris?
No, I've got M2.
M2, okay. Same thing.
Pretty much. Close.
A globular cluster. And what's Gary got?
Right now, I'm refocusing.
Oh, okay. All right.
And I've got the Eastern Veil right now.
I was wondering if that's what you had there. Yeah, it's really faint.
Yeah, well, that's just because I haven't stretched it or anything. But this is, I'm taking a 3-minute right now. This is a 2-minute we're looking at right now.
Yeah.
We can see a few wisps up in the upper left corner.
Yeah, there, and it's kind of, it goes from here all the way up to there.
And we actually did a whole episode of the virtual star party where Gary really just took us on a tour of the whole area. It was quite nice. So this is like just these wispy fragments of all of this, I guess, large star that had detonated thousands of years ago. And so you just got a bunch of different pieces of it are all, was it the Crescent Nebula and the Veil Nebula, and a bunch of pieces that are all part of this same object.
And again, for contrast, let's see. Did we have? I think we had the Dumbbell Nebula up before.
Yeah, that was me. I can put that back up if you want.
Sure. Yeah, if it's readily available there.
Yeah, it's right here.
Okay. So to contrast the dumbbell, which kind of has a very disc-like shape. I mean, there's some lobes to it, so we can see roughly disc-like though, but a lot more symmetry, a lot more organization visible with the dumbbell than say with the Veil. The Veil is caused by a massive, violent explosion from one of the most massive stars present in the galaxy. The Dumbbell, on the other hand, is a star like our Sun when it reaches the end of its life, and so its death is a lot more gentle, and so the gas expands away from it roughly in a spherical shell. So when you look at planetary nebula, like the Dumbbell here, they have a lot more symmetry. When you look at something like the Veil or the Crab Nebula, it really looks like somebody just took some kind of like white paint and threw it on the sky. And you can get kind of a very random looking pattern to it because the event that creates it is so much more violent than, say, the death of a smaller star like what will happen to our Sun in about 5 or 6 billion years. So
let me just speak for everyone and say, Thad, I'm really glad you showed up. You're fantastic.
Yeah, me too.
Thank
it is
you.
great
Thank
to
you.
have your, as an astronomy teacher here, a professor
thanks,
actually
glad.
helping as well. So
glad to be here.
What is a safe distance? This is from PW Pollard on YouTube. What is a safe distance in light years for a star to go supernova and not negatively affect the Earth?
Oh, that's a good one. Well, let's see.
I've heard it's not that far. Phil Plait did
Yeah.
his book Death from the Skies, and he said that that it really has to be in your backyard for it to cause us some damage. But it's the gamma ray bursts where we've got something really to worry about, because a gamma ray burst, you got these focused beams of high energy gamma radiation that will strip the ozone layer right off the Earth in one blast. And so even if a gamma ray burst goes off within our galaxy, halfway across the galaxy, if those death beams are pointed at Earth, we've got ourselves a bit of a problem. So
That's a problem, yeah. But just for an example, if we look at nobody's going to have it to look at right now. But the supernova 1987A, which was visible in the Large Magellanic Cloud, it was the first supernova detected in 1987. And the amazing thing about this, it was one of the astronomers who was working at one of the observatories in Chile, walked outside, looked up and said, "Oh, wait, that magnitude 1 or 2 star wasn't there before."
Yeah.
So I mean, the discovery for this was pretty amazing. Now, we didn't quite catch it on its way up, so we still don't have a really good nailed-down model of what exactly happens before a star goes supernova. But just, for example, about 10 or 11 years after it became visible to us, there was about a 1 light year across debris field expanding away from it. So you've got stuff flying out from the supernova at roughly 1/10 the speed of light. So my estimate, and Phil might have something a little bit more refined than this, I would say within 10 light years you're going to feel some kind of local effect from it. More than about 50 you won't. So, in that 10 to 50 range, okay, you're going to get increased irradiation from gamma rays and whatever else from the explosion itself. But yeah, there's no star within 50 light years of us that will go supernova.
Yeah, and this is, I recall having a conversation with Pamela at some point about this, and she was saying, yeah, that exact thing, that all of the potential supernova candidates within the local area have been identified, and we don't have to really worry about any of them going off. So we're safe from any supernova explosion. Got a question here. If I buy a pair of Celestron Skymaster binoculars, what will I be able to see? So I'm going to guess he's talking about like the 25 by 100 binoculars. Those are the Skymasters, aren't they? They're pretty good resolution. I mean, they do a bunch of them, I think, but one of them is like upwards of 25 by 100. So I mean, they're pretty great binoculars.
I've got a pair of 25 by 100s, and the two things I absolutely love through them: the moon. After Planet Fest 2 weeks ago, when Curiosity landed on Mars, I happened to have them in the back of my car. I ran back down to the parking garage, got them, and was giving people views of the waning gibbous moon out in front of the Pasadena Convention Center. And the thing is, with binoculars like that, it really feels like it's in 3D. If you get the separation between the two sides just right, I mean, your eyes and brain start putting the images together. It really feels like it's popping out at you in 3D. So if you're getting them, that's one object you will never tire of looking at through them. The other one's the Pleiades. The Pleiades, again, really bright, gorgeous star cluster, and in a 2 or 3 inch scope, yes, you see a lot of stars, but again, with these 2 4-inch telescopes, essentially one for each eye, you really get a feel of a few 400, 500, maybe bright blue B-type stars. So again, these are very hot, very massive stars that put out more blue light than they do red light, so they appear bluish. Pleiades just look absolutely gorgeous through those things. Some surprises you'd get with them. The rings of Saturn show up pretty easily in a 25 by 100 pair of binoculars. You won't be able to say make out like the Cassini division or anything, but other things like Titan and maybe even a few of the other moons might show up if you have a good dark night to look at it. Jupiter and its 4 moons and the 2 equatorial bands show up very nicely in a pair of 25 by 100s. And then there are all these other like nebulae and deep sky objects. If you can get away from city lights, things like the Andromeda Galaxy, these larger globular clusters, these larger
cluster,
double clusters, awesome through these.
Yeah.
So I had them with me last weekend up on the Central Coast. So good dark skies, easily seeing stuff down to magnitude 6, and just poking around through Scorpius and Sagittarius with them. It's like, okay, there's that globular cluster, and there's this nebula, and this nebula, and okay, this is where they are relative to each other, because you have a big enough field of view, you can actually just kind of slew around and just pick out object after object after object with these binoculars.
Yeah, I mean it's just a different experience, It's just, if you're going to be doing astrophotography, then you really need a telescope. It's got to be, you're going to want a guided mount, and you really want to be able to capture these long exposures. If you're just laying out on your, in your backyard and you're looking up at the sky and you just want to, like, boom, there's the moon, boom, there's Jupiter, then binoculars, nothing really compares, and it's just 2 different experiences. And I mean, those binoculars, I mean, you're in for $100 and you're getting you're getting a nice pair of
The one thing to be
astronomy binoculars. So I mean, you'd be crazy not to get a pair of nice astronomy binoculars if you want to just start to investigate this as a hobby.
I'm going to break in here. I have M51 right now.
I see it. Yeah, I've got zoomed here. So why don't we explain this? It's a little lower on the horizon, isn't it, for you now?
Yeah, it's right above my house. I thought I'd grab it before it went underneath.
Yeah,
Okay.
yeah. That's M51, right?
Correct.
right.
Yeah.
So the Whirlpool Galaxy in Canis Venatici, I can't vouch for the pronunciation there, but essentially, if you have the handle of the Big Dipper, and you look underneath the bright star Alcade at the end of the handle, that's the vicinity that you want to look in for the whirlpool. It's not visible to the naked eye, but hey, if you got those 25 by 100 binoculars, this is something that could show up in them.
Yeah, a little smudgy bit.
Yep. The one thing that we've seen here, if we're going to talk about supernovae, this galaxy has had a preponderance of supernovae. I mean, typically in a galaxy you might see 1 or 2 supernovae every 100 years. With the Whirlpool, there have been 3 in the past 17 years. The most recent one became visible at the beginning of June 2011, and I missed imaging its first appearance by 24 hours. So I was out with the scope the night before and shot, and then I saw the announcement a few days later that they'd found a supernova and kept digging through my images. It's like, oh, just missed it. So, but this is a galaxy with spiral galaxies. You have a lot of star formation going on, so you have a lot of new, younger, hot O-class stars forming. So they'll pop off as supernovae, in a galaxy like the Whirlpool Galaxy a lot more frequently, with it having that huge amount of star formation like it does.
Yeah, and I mean, it's interesting to see. I mean, we've done this sort of week after week, and I've gotten to really know Stuart's sort of imaging capability, and it's fine. I can just tell, like, he's had better views of it in previous weeks, just because it's been higher in the sky, and now as it's starting to get lower in the sky for him and closer to his house, as he says, it's getting a little more atmospheric disturbance, so we're not quite seeing it as crisply as we had in previous weeks. So, but you can really see, you can make out that whirlpool, that really beautiful spiral structure there, and then it's got a little satellite galaxy, right, that it's been interacting with, or are they separate?
No, it's another smaller galaxy that's passing nearby the whirlpool, and under long exposure images you can see that smaller galaxy pulling a stream of material away from the whirlpool and toward itself. So so there's definitely interaction there, and I'm sure that interaction is part of what's spurring the higher rate of star formation.
Yeah.
So one other quick point for the person with the Skymaster binoculars: you will need a good tripod with those. They weigh something on the order of 11 or 12 pounds, or about 5 kilograms if you're somewhere outside the U.S. So you can't exactly just hold those up with your arms and expect them to stay in one place. You'll need to get a good tripod for those.
Yeah, and it's one of these situations where you've got this higher resolution. I mean, with binoculars, right? The Skymasters. Someone mentioned this on the comments that the Skymasters come in like 15 by 70 or 25 by 100, and so the 15, that first number, is your magnification. So you're either going to see things at 15 power or 25 power. The second part is the size of the lenses, right, in millimeters. So bigger lenses, better, fainter objects that you can see. But they're long. I mean, they're great big binoculars. I mean, they're a really beefy pair of binoculars. So sometimes, again, pick up like a nice pair of like 7 by 35s, and that's a nice place to get started. You've got 7 times the magnification. You can see the moon looks great. You can't really see much with Saturn or Jupiter until you move into the higher magnifications. But yeah, you're right.
Yeah, you can see the moons really easily with any binoculars, really.
Yeah.
You might have
to that crescent shape of Venus.
Right. You might have to prop the binoculars up on the roof of a car or something to hold them still. But you can pick up the moons of Jupiter with a pair of 7 by 35s.
I'm gonna. So Gary, you've been on the same object for a while. Was this the coat hanger?
This is the coat hanger. Mm-hmm.
Yeah. Okay. But we can't see the whole thing.
Comment. Well, I think I'm off a little bit.
Yeah.
I'm not real good at what the coat hanger is. I think this is
That's the coat hanger,
Oh,
yeah, and then you can see
this
that,
is
and
the
then
arm
that's the
piece here.
so that's the hook is the thing on the right there, and
Mhm.
the bottom of the coat hanger is what's going on, sort of from top to bottom there.
Yeah,
So
going off the
if you had a
bottom
little bit more, if it was a wider field of view, you'd be able to see it.
Yeah, but the asterisms are those are the best in the binoculars. And just while you were talking about
Absolutely,
that,
yeah.
I picked up the Celestron Mini Giant. I think it's a Mini Giant 9x63, and that's a real good in between. You get enough, but you can still hold it without shaking all over the place.
So let's see here. So Tom, can you click on the presentation mode on your view there, so you can get it to be sort of full screen like what Corey's doing? And then Corey, you've got. Are you on M2 or M17?
This is M13.
M13. Yeah.
Yeah.
This is the Great Globular Cluster in Hercules.
This is really exciting for me because I've never ever imaged anything deep sky before.
Oh, wow.
Well,
So-
congratulations.
Well,
you did a
congrats.
fantastic job, man. This is awesome.
I'm using a homemade equatorial platform that I built. Started yesterday and finished this morning for my 10-inch Dob. So
really
is
just
a-
breaking this in.
yeah, this is the first test. I haven't quite. As you can see, there's some streaks in there. This is a 10-second exposure. But
I would love that if there's a way that we could see a picture of it. Did you take a picture of it yet?
yeah. Oh, yeah. I took a bunch.
Can you take a screenshot of it? Show us a
Yeah.
screenshot of it?
Let's see.
But I'll show where he's looking at. This is another one of my favorite objects. So this is the Constellation of Hercules, and it's nice because it's sort of very similar, very close to the Summer Triangle. So there's the Summer Triangle, right? Vega, that really bright star that's almost overhead right now. Cygnus and Aquila. So there's Cygnus, and Deneb is the bright star, and then you got Altair, right? So these three stars make the Summer Triangle, and then near them is Hercules, and you can really Hercules really looks like what it's describing. You've got sort of the chest of Hercules, you've got his arms and his legs, and so I always say that this is his club, but actually I guess it's Draco's head. But I always see it as this club. But here's is the Great Cluster in Hercules, M13. It's another one of those really nice objects to easily find because it's on the right-hand side of his body. You can see these two stars, and sort of 1/3 of the way down is the Great Cluster in Hercules. And so it's, again, a really nice object. One of the brightest, I guess it's one of the brightest clusters that we'll get in the northern hemisphere. I think the Omega cluster is a little nicer in the southern hemisphere, right?
Yeah, let's see. The Great Globular in Hercules is estimated to be between about 500,000 and 1 million stars, which is incredible. But the Omega Centauri, the biggest globular cluster in our galaxy, is estimated to be upwards of 2 million stars, and it's so many that in fact it's kind of oblong. It looks a little bit more like a football or an egg than a ball because of the motion of the stars in there. Kind of stretch it out a little bit in one dimension as opposed to looking like a ball like just about every other globular cluster.
And I think so here's Corey's view here, and I think it's important to see, right, that this is a Dobsonian. It's a 10-inch Dobsonian, so it's, apart from Gary, it's probably one of the largest light-gathering telescopes we've got here at the Star Party tonight. And it's only a little smaller than what Gary has, but the problem with the Dobsonians, they're very inexpensive. I mean, I don't know, what does a 10-inch Dobsonian cost?
About $400 to $500.
Yeah, $400 to
$500.
$500. For a really gigantic telescope. But the problem with them is they don't, the tracking is very difficult. And so, we've had a bunch of star parties where Corey has been heroically tracking the moon and Saturn and things like that, but he's having to hand guide it the whole time. And so I can see that just got under his skin, and it's all he could do to solve the problem. So what's your solution here?
Well,
Kind of crazy, sledge underneath it.
yeah, that's basically it's the idea is you take a normal equatorial mount, the idea of it, and flatten it out using a cone projection. It's hard to explain, but there's two sets of bearings. There's a north and a south, and those wedges you can see at the bottom are the north bearings, and the south is basically just a pivot point. So the way you make them is that you make them for your latitude, and you project a cone onto that points at Polaris from your latitude, and then you basically figure out where the cone intersects these vertical areas, and you cut them, and then it basically just rolls along at a speed set by the motor, which is the little black box down below on the right, and that just slowly moves it just like it would on a normal equatorial mount for a tripod.
And so is this mount only really good from your deck?
No, it's usually good between about 10 degrees or so, either north or south of me, and then you can just prop it up.
Right. Okay.
But yeah, they're really only good for your own latitude. But I mean, you can buy them, and I just didn't want to spend the money on it, and I like to build things, so.
And so what did that cost you all in?
I used a lot of stuff around my house, but if I would have bought everything, it probably would have been about $70. So
that is fantastic. Well, that first image made it all worth it. I could see now you're down a whole new rabbit hole, right? Which is to make this mount work.
Very impressive.
That's beautiful. That's phenomenal.
Corey, you have made any makers who are watching us very proud with that. That is that is terrific.
Oh, thanks. It was a lot of fun. I was kicking myself because I ended up buying one, or not buying one, but seeing one that I could buy for about $350, and it probably is made better than the one that I built.
Oh, I see. So
that's how the motor, if you can see
probably
that.
Should have gone for that one, yeah.
Yeah, that's how the motor attaches to. It's just basically a screw that spins it along. So.
Wow.
It's super DIY.
No, that's fantastic. That is awesome. That's beautiful. Congratulations, man. I look forward to your deep sky work. And already, I mean, this is, you're going to have to do some tweaking, but this is phenomenal.
Not bad for my first one, I guess.
Yeah, it looks great.
All right, on to the good stuff.
All right, we're going to move on to what Gary's got. I see some kind of dark nebula here.
Yeah, this is a new one that I haven't been across. I just found looking through the star charts. This is the Parrots Head, and again, is in Sagittarius region. So it's in the very dense region, and it's the dark nebula. I was trying to stretch it a little bit to get a little more detail.
And so you've never seen this before?
No, never directly imaged this.
It's good. I would add it to your list, Gary. I like it.
Okay, well, that's one on the list. That is the Parrot's Head.
And so this is a dark nebula, though.
Yeah, and I'm not sure where they come up with the Parrot's Head. Maybe this part here.
Yeah, I think
maybe
that's
the beak toward the upper left. Maybe.
Yeah, I think I see it.
Yeah, so I always like to try to find something new, but starting to run out of them. Universe needs to make new stuff for us.
Give it a few thousand years, I guess. Yeah.
Well, you keep trailing along through Sagittarius and Aquila and Cygnus. There's just so much you can turn up in there. I still remember one of the first nights I was out imaging stuff. Again, like you finding the dark nebula there, I was just, I'm going to scan along and let's see if there's a patch here that looks interesting to image. And after taking a few shots and then getting home and stacking them and all, it's like, wow, there's a lot of detail in that dark nebula. So it's kind of painting in the inverse, where you use the stars and then you as your backdrop, and then you're seeing what you can tweak out of the things that are interfering with your being able to see the stars and getting the shape out of that. So definitely a good job there with doing that with that shot of the Parrot's Head. Very nice.
Thank you.
That's fantastic. Yeah, definitely add that one to the list. I'd love to see like a longer exposure, multi-filtered version of that. Add that to your list of further exploration, Gary.
Okay.
I see some potential there.
I've got another open star cluster. I'm just sort of poking around Cygnus here. This is NGC 6883, and I just think it's a pretty collection of stars.
I can see some really red stars in there too. That's really nice. Yeah. So these are the kinds of objects that almost like a telescope is too much, that you really need to look at them with binoculars to really see them in perspective, because then then you get, I don't know, they just look a lot nicer in binoculars, I find, That's really nice. So we're kind of running sort of at the hour and a quarter now, so I think we'll probably start to wrap things up. So now there's a few things to mention to people. So the first thing is that I guess next week we'll be doing another Star Party next week, and then I'm going to be traveling to Dragon Con. So if anyone's planning to go to Dragon Con, I will be there with Pamela and Nicole and Phil Plate, and a bunch of us are all going to be there. We're going to do a bunch of things. On the Thursday night, we're going to be doing a Star Party with the Atlanta Skeptics, and so that's going to be on Thursday the 30th, and we're actually going to be broadcasting the presentations as Hangouts on Air out onto the internet. So if you can't come, you can watch that. But I think there's still some tickets available if you're going to be in Atlanta and you want to hang out with all of us. And then we'll be all at Dragon Con, so we're going to do a live episode of Astronomy Cast. We're going to be doing a bunch of panels and I don't know, just hanging out. So if you want to hang out with us, we'll be all at Dragon Con. And we're on hiatus with Astronomy Cast and the weekly Space Hangout. We're going to be bringing all that back in September once we get back from Dragon Con. So, and we have a little more time on our hands. So, and a lot less colder water to swim in. So that's the big problem right now. They're all just outside all the time. Okay, great. So once again, thanks to everybody who joined us, and thanks to Chris. I don't know what Chris has got here. One last picture. What is this, Chris? And I think I'm seeing a meteor
that was
there.
the open cluster. You're seeing a satellite. That's the open cluster of M34 there.
Yeah.
Yeah.
And thanks to Corey for jumping in and showing us his DIY. That was fantastic. Thanks to Gary down in Los Angeles.
Thank you, everybody.
And thanks to Stuart and that lovely M51. That's really great.
Thank you.
And thanks to Tom. I know, Tom, you didn't get a chance to display much this week, but we'll get you more up to speed for next week.
Hey, at least I got clear skies for a change. I've been trying this valve for 3 months now.
You're in Oregon, though, right?
Yeah, I'm in Oregon.
Yeah.
I'm just outside of Portland.
Yeah, well, there you go. It's this, it's awful here in the Pacific Northwest.
Yeah, it's just been horrific. And what's weird, we just got through a big heat wave, and now you need a coat.
I know. Same here on Vancouver Island too. It's been weird. We got the opposite weather that everybody else has had. Everyone's had this horrible drought, and we've had this horrible cold summer until just the last couple of weeks. It's been nice and hot, and now it's back to cold. So, and Pat, thanks for jumping in and bringing the knowledge. That was fantastic. I really appreciate it.
Yeah, no problem. And I thought I saw. I don't know if this was addressed earlier, but I thought I saw Phil Plate tweet earlier that today is your birthday, Fraser.
Yeah, it is my birthday. 41.
Okay.
Happy birthday.
Happy birthday, Fraser.
Fraser, as a birthday present, real quick, I've got M29. This is your something we haven't seen before. It's a little star. It's a tiny little, cute little star cluster.
I love it.
Yep. Right off of the center of Cygnus there, off the heart of the swan.
That's fantastic. Well, I couldn't have a better birthday party, guys. I really appreciate it. Thanks to everybody for watching, and thanks to everybody for coming and hanging out. This is fantastic. 1, 2, 3, 4, 5 telescopes. This is great. All right. We'll see you all next week.
All right,
Bye.
Thanks, Fraser. See you.
Bye. Take care.